Let's talk about AI agent skills and why almost every serious AI coding platform has started using the same open standard for them. To understand why, you first need to understand the gap they were built to fill in. Large language models are great at knowing things. Ask one about distributed systems, programming languages, or literally the flying speed of a bird, and you will get a solid answer. That is not the problem. The problem is they don't know how your specific workplace operates. They don't know that your finance team follows a process to produce a quarterly report. They don't know the order of those steps, the edge cases, or the little judgment calls built up from years of experience. That kind of knowledge, the how-to knowledge, doesn't come built in. So when an agent hits a task like that, it is stuck with two bad options. Either someone types out every single step in the prompt every time, or the agent just wings it. Neither works at scale. Skills solve the problem. A skill is simply a way to hand step-by-step instructions to an agent in a structured, reusable way, and the format is surprisingly simple. It is just a Markdown file called skill.md sitting inside a folder. That is it. The file starts with a small block at the top called YAML front matter, which has two required fields. The first is the name, which is just a label. The second is the description, which is the most important part. It tells the agent what the skill does and when to use it. Something like use this skill when the user needs to generate a compliance report. That one sentence is how the agent decides whether to reach for the skill or not. So writing it clearly really matters. Below that block, you write the actual instructions in the plain Markdown. The steps, the rules, the logic, examples of good output, and whatever else the agent needs to get the job done correctly. The folder can also hold 3 optional subfolders, one for scripts like Python or JavaScript code, and one for reference documents, and one for static files like templates. Simple but powerful. Now, a real-world agent might have dozens or even hundreds of skills available. You can't load all of them into the agent's memory upfront, or you would use up the entire token budget before the user even says hello. The solution is something called progressive disclosure, which is just a fancy way of saying the agent loads things in stages as they become relevant. At startup, the agent only loads the name and description of each skill. Just a handful of words per skill, like a table of contents. When the agent gets a request and recognizes it matches a skill, it loads the full instructions for that skill. And only when a specific step in the task actually needs a script or a reference file, then it loads those too. This way, the agent always knows what it is capable of, but only loads the details when they are actually needed. One thing that often gets overlooked is that skills can work together. A big task doesn't have to live in a single skill file. A high-level skill called produce monthly report might internally call 2 smaller skills, one to pull data from an API and one to format it into a PDF. This is the same idea as writing clean, modular code. Small focus pieces that combine into something bigger rather than one giant file trying to do everything. It is also worth clearing up a common mix-up. Skills are not the same as system prompts. A system prompt sets the agent's overall personality, its tone, its limits, what it will and won't do, and it is always loaded, always active. A skill is different. It is task-specific. It only gets loaded when triggered and it handles one particular workflow. If you have been cramming detailed step-by-step workflows into your system prompt, you have basically been doing by hand what skills were designed to handle automatically and paying extra in tokens every single time. So here is a simple way to know when to write a skill. If you keep typing out the same instructions over and over again, write a skill. If a workflow has its own logic that evolves on its own, write a skill. If a task has branching steps, calls to external tools, or have a very specific kind of output, write a skill. If it is a one-off thing you will never do again, just prompt it. Skills are for repeatable work. Skills also are not the only tool for giving agents knowledge. There are few others worth knowing. MCP or Model Context Protocol connects agents to external APIs and services, expanding what they can do. But MCP just gives the agent reach. It doesn't tell the agent when to use a tool or what to make of the result. RAG, or Retrieval Augmented Generation, pulls in relevant facts from a knowledge base at the moment they are needed, like a reference library. Useful, but it doesn't teach process. Fine-tuning bakes knowledge directly into the model itself, which is permanent but expensive and hard to update. Skills sit in their own lane, handling procedural knowledge, the steps, the logic, the judgment calls. And because they are just files, they are easy to update, version control, and move between platforms. Skills and MCP often pair well together. MCP gives the agent the ability to call something external, and the skills tells it when to do that and what to do with the result. Something that doesn't get talked about enough is that skills are a team resource. Since they are just Markdown files in folders, they can live in a Git repository like any other code. That means your team can review them, improve them, track changes over time, and deploy them together. The agent's knowledge stops being buried in someone's head or hidden in a long prompt. It becomes something everyone on the team can see and work with. The skill.md format is also an open standard published at agentskills.io. Claude Code, OpenAI, Codex, and many other platforms have adopted it, which means a skill you write once works across platforms without any rewriting. There is an idea from cognitive science that puts all of this into perspective. Human memory works in different ways. Semantic memory stores facts. Episodic memory stores experiences, and procedural memory stores how to do things, like riding a bike or driving through a busy city. Modern agent design is starting to mirror this. RAG and knowledge bases cover factual memory. Conversation history covers experiential memory. And skill files cover procedural memory. The way we build agents is starting to look a lot like the way human memory works. One last thing worth taking seriously is security. Skills that include executable scripts can access your file system, environment variables, and API keys. That is what makes them useful. But it also makes it risky to install skills carelessly. Researchers have found that some publicly available skill files contain prompt injection, where the skill is designed to manipulate the agent's thinking, or tool poisoning, where it hijacks external API calls and in some cases outright malware. Before you use any skill you didn't write yourself, look for network calls to suspicious domains, instructions telling the agent to ignore its own rules, references to files or credentials the skill doesn't need, and overly broad access to the file system. Treat installing a skill the same way you would treat adding a third-party library to your code base. Read it, understand it, then run it. To wrap it up, skills are the way you give an agent procedural memory, a markdown file in a folder that teaches the agent how to carry out a specific repeatable task. They load conditionally, work efficiently, and combine with each other and with external tools, and live in version control just like the rest of your code. They work across platforms, they are a team asset, and they are quickly becoming the standard way that serious teams encode real-world workflows into their agents. The model already knows a lot. Skills are how you teach it the rest. If you find the video useful, do like the video, subscribe to my channel, and I'll see you in the next one.